Hello viewers, let's talk about AWS Fargate today. So if you're new to Fargate or if you want to have a quick study on Fargate, so this video is for you. So let's get started on AWS Fargate. So AWS Fargate is a serverless container platform where you can run your container on EC2 instance managed by AWS. This relieves customers from provisioning, configuring or scaling of VM to run containers. The compute instance powered by Firecracker are micro VMs that run in AWS managed VPC invisible to customers. AWS Fargate is a serverless pay-as-you-go compute engine that lets you focus on building applications without managing servers. AWS Fargate is compatible with both Amazon Elastic Container Service as well as Amazon Elastic Kubernetes Service. AWS Fargate is a service that provisions serverless computing resources to run AWS ECS and AKS containers. AWS states that Fargate allows you to focus on building your application when you let Fargate provision and manage the infrastructure required. Think of it as a container on demand with no underlying manually created infrastructure that are quick to launch and scale, where you manage everything at the container level. You specify the resources your application needs to run, and Fargate handles the provisioning of compute resources in an isolated and secure instance. Fargate determines the correct amount of computing resource required, which means you don't need to worry about selecting instance type or having to scale the cluster capacity. With Fargate, you only pay for the resources required to run your containers as they are consumed, which means you eliminate over provisioning and paying for servers you don't need. Fargate task pods run in their own kernel, providing a secure and isolated compute environment, which provides an isolated workload and improved security as a consequence. So major AWS clients like Vanguard, Accenture, Foursquare, and Ancestry have selected Fargate to run their mission critical applications. So here you can see without Fargate you need to manage the infrastructure, and with Fargate you don't need to manage the infrastructure. You just build the container image, define memory and compute resource required, runs and manage the application, and pay for request compute resource when used. Application isolates by design. So some of the use cases where you can think of using AWS Fargate is first is web app APIs and microservice. So build and deploy your application APIs and microservice architecture with the speed and immutability of containers. Fargate removes the need to own, run, and manage the lifecycle of a computer infrastructure so that you can focus on what matters most, your applications. Run and scale container workloads. Use Fargate with Amazon ECS or Amazon EKS to easily run and scale your containerized data processing workloads. Fargate also enables you to migrate and run your Amazon ECS Windows containers without refactoring or re-architecting your legacy applications. Another use case is support of AI and ML training applications. Create an AI and ML development environment that is flexible and portable. With Fargate, achieve the scalability you need to boost server capability without over-provisioning to train, test, and deploy your machine learning models. Next is optimizing cost. With AWS Fargate, there are no upfront expense. Pay for only the resources used. Further optimization with compute saving plans and Fargate spots, then use Gravitation to power Fargate for up to 40% price performance improvements. AWS Fargate is a technology that you can use with Amazon ECS to run containers without having to manage servers or cluster of Amazon EC2 instance. With Fargate, you no longer have to provision, configure, or scale cluster of virtual machines to run containers. This removes the need to choose server types, decides when to scale your cluster, optimize cluster packaging. When you run your Amazon ECS task and service with Fargate launch type or Fargate capacity provider, you package your application in containers, specify the operating system, CPU, and memory requirements, define networking and IAM policies, and launch the application. Each Fargate task has its own isolation boundary and does not share the underlying kernel, CPU resources, memory resources, or elastic network interference with another task. We can use the Fargate launch type or Fargate capacity provider to run your Amazon ECS tasks and services. To use Fargate, you can package your application in containers, specify the operating system, CPU, and memory requirements, configure networking and IAM policies, and launch it. There is no need to maintain a base CPU and RAM capacity to host containers. We can tell AWS how much resource a task needs and leave the rest of the task to AWS. Each Fargate task has its isolation barrier, so it does not share the underlying kernel, CPU, memory, or elastic network interface with other tasks. So how does it work typically? So to utilize Fargate to manage the deployment of a replication container, you need to have a container stored in container registry like ECR or Docker Hub and set up a task and cluster via ECS or EKS. The steps in the deployment cycle are build a container image, host a registry in Amazon ECS or ECR or Docker Hub, choose an orchestration service either Amazon ECS or EKS, create a cluster taking the AWS Fargate options. AWS Fargate with Amazon EKS is available in all Amazon EKS region except AWS GovCloud. Each pod that runs on Fargate has its own isolation boundary. They don't share the underlying kernel, CPU resources, memory resources, or elastic network interface with another pod. Network load balancer and application load balancer can be used with Fargate with IP targets only. Fargate exposes service only on the target type IP model and not on the node IP mode. The recommended way to check the connectivity from a service running on a managed node and a service running on Fargate is to connect via service names. Pods must match a Fargate profile at the time they are scheduled to run on Fargate. Pods that doesn't match a Fargate profile might be stuck at pending. If a matching Fargate profile exists, you can delete the pending pods that you have created or schedule them onto Fargate. Demonstrate daemon sets are not supported on Fargate. If your application requires a daemon, reconfiguration that daemon to run as a sidecar container in your pods. Privileged containers are not supported on Fargate as well. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.